we are now going to welcome Vijay Krishnan to the stage. He is the Chief Technology Officer and co-founder of Turing, who will now solve our AI problems for us. So I have to tell you, as you know from he's an alumnus from the University of Technology, Bombay, as am I. So that makes me. And I have to say this: the first time I've been turned down. Jonathan Siddharth, who is his co-founder and CEO, was supposed to be here, as you've probably seen on the program, and he's meeting with Sam Altman today, and therefore couldn't be here. And so I'm sitting saying, I've never been ditched for Sam Altman before, so I must be doing something right. But that speaks to sort of the company Turing that Vijay, and so when you address us now, it's Vijay K and Vijay G. And all the years I've been doing this, there's never been a Vijay on the stage with me. So this is the first. Tell us a little bit about yourself, Vijay, and Turing and what you do there.
Sure. Hello, everyone. I'm Vijay Krishnan, and I'm founder and CTO at Turing. In my past life, I want to say 20, 25 years ago, I was an active machine learning researcher, publishing academic papers and everything. Though ever since after IIT Bombay, I went to Stanford. I continued to be an academic researcher there, but soon after that, I've been a serial entrepreneur. I did one company in the content recommendation space, which got acquired around 8 or 9 years ago. And Turing is the second company that I've founded, also an AI company. Now at Turing, we have one of the largest talent platforms in the world with more than 4 million software engineers, data scientists, other kinds of professionals from over 100 countries around the world that we vet through a series of tests to identify the top few % of the world's talent. And this allows us to serve our clients along 2 business lines we are in today. Our first business line is what we call this AGI advancement, and in that particular business line, we work with OpenAI, Anthropic, Google, Meta, a whole bunch of others, Microsoft, Amazon, and others on helping their models get better at a range of areas. Specifically, we get involved in the part involving expert human feedback, which is a key ingredient to make these models better, in addition to the general purpose pre-training data on the internet, enhancements in algorithms and everything. So we can get into more details in that, but that is what we do in this one business line. In the other business line, we do AI consulting and implementations for Fortune 100 companies. And we find an interesting synergy between both of these in some ways. On one hand, of course, the fact that we are at the frontier of AI, helping these companies all the way from GPT-3, GPT-4, the reasoning models, the GPT-5, the latest Gemini models, and all that stuff has given us a nice front row seat into the advancements of today, as well as what is around the corner, and that has made us an effective partner to Fortune 100 companies. But the reverse is also true, because the fact that we have been involved in AI consulting and implementation with the Fortune 100s has also given us a much more acute sense of where the models fail today when it comes to real world. Like all our frontier AI clients tell us the following today, that, hey, we recognize that the solution to getting the models to crack Olympiad level problems is not to get it to solve Nobel Prize math. It is, can you automate some real work in the industry and do that at sufficiently high reliability and solve all the other problems that many of you pointed to. So we are very much helping along those lines as well.
So one of the things I think would be helpful to talk about, something we actually didn't talk about yesterday, was give people a sense of what it is like in these frontier model companies around training. Because I think we sort of read the news and everybody's trying to learn more about it, but what actually happens when they're training these? Because you read about it takes 6 months to a year to go from GPT-4 to 5 or whatever they're using. God knows, latest generation of this stringing from hundreds of thousands of servers to millions of servers together. But what is the sort of the sense of what is happening at these companies day to day in their sort of race towards AGI, ASI, whatever our phrase of choice is?
Great, yeah. So, great question. So, this area has very rapidly evolved in the last. I mean, we've started working with OpenAI nearly 4 years ago, and certainly, every quarter seems like forever in terms of the progress. Every 2 quarters, the whole business looks very different. The way these companies operate look very different as models have made substantial improvements in a different area, and certain kinds of low-hanging fruit are tapped. So I would say that for the first couple years in the last 4 years, a lot of the focus was straight up on making the models just bigger. At that point, you would hear more about these so-called scaling laws.
Yes.
The assertion being that keep everything else constant, just grow the size of the models, which of course in turn means the more compute, more GPUs, all that stuff. And grow the size of pre-training data, and you can just keep making steady improvements. That was sort of the idea. Now the point is that scaling laws of that classic kind have certainly hit their limits. I would say even probably by sometime last year. So to the point where currently our best guess is that most of the latest frontier models maybe have about 1 trillion odd parameters. I don't think there's very many people that believe that taking it to 10 trillion parameters will improve anything. So it does seem like we've hit the limits of the model capacity here. And when it comes to pre-training data, like most of you may know that these models are virtually trained on the entire internet, news articles, code bases on GitHub, all sorts of things. There too, we have hit something of a wall. So now that in turn, I would say, leaves a couple of other vectors of improvement. Like with the reasoning models that launched last year, the idea that you could make the models think more, engage in more sort of deeper reasoning, generate these intermediate tokens, and thereby generate better outputs was one important line of attack. And I think there's still a lot to be said there. That was in some ways the very basis of creating all the sophisticated agents that we want to create, because many of these are these kind of multi-step things where the model or the agent that you build on top of it can correct after its errors and so on. It's not quite like, here's a question, give me the right answer in one shot. So this has been certainly one powerful line of attack, and a lot of training methods, etc., around this. The other thing which I think has been important even for the last 4 years, but I think that is nowhere near being tapped out, is this expert human feedback for post-training. So it turns out that compared to the size of the entire internet, what a team of maybe 20 or 40 human experts in one specific area can do over 3 months is not substantial in terms of raw, let's say, bytes of feedback. But it turns out that these things, very carefully crafted, can significantly move model performance in different areas. So pulling together expert humans to identify model weaknesses when it comes to coding, multimodality, which is to say understanding images, audio, video, and so on, understanding different kinds of agentic behavior, the capability of the LLMs to call external tools to operate your computer like you, and that is what goes into all these operator models, and even this PhD level physics, chemistry, mathematics, all this stuff. It turns out that there is a lot one can do with human experts, and particularly as it relates to making these models good at different real industry use cases. I think that is very much the next frontier, getting various human experts in there, evaluate model performances, and improve them.
Okay, so let's go back to the elephant in the room. So this is good because this really helps us understand, because one of the things you can't sort of solve some of these things. You can't scrape the internet and get answers to how do you prove the theory of relativity or something. Maybe you can, actually, I don't know about that. But they're talking a very big game now about superintelligence. Mm-hmm. And do you think, first of all, I'm not even sure how we would define superintelligence, but is it achievable? I mean, and when do you think we'll get there?
So nothing in theory stops us from achieving it, but it is certainly not right around the corner. Certainly, if one held the most optimistic view, you could maybe say a decade out or something, but it could well be before that. So I think while this is an interesting question to figure out, I think probably the more interesting question is how will the trajectory of what are the kinds of high GDP useful work that an LLM can do today, and how much more useful work can it do next year, the year after, etc. I find that a little easier to model than this one.
Yeah, yesterday when we were talking, he gave me a great expression. He called it AUI. So I've heard of AGI, ASI. I've never heard of AUI. What the heck is that? He says artificial useful intelligence.
Right.
And I think that's something really important for all of us to keep in mind, because, when we focus on these, the way I think about it is that we talk about, the best marathon times, and most of us can't run, 10K. And so I think if we should focus on completing our 10Ks, we'll be doing so much better.
Though this is I think quite a key question if you are a frontier model company like the ones we are working with, because absolutely it has very, very significant implications for their business, for maybe what they tell their investors, the whole thing. But if one is a large enterprise that is looking to get most value out of it, fortunately, we don't have to deal with that question as much.
And they're plenty useful now, right?
Yes,
you don't need to wait for something in the future, because we always like to sort of think of everything as a horse race. And I know you work with all of them, so I may be putting you a little bit in the spot here, but how do you compare these different models in terms of the capabilities? Because my sense is they're actually pretty similar, and some, like today, Anthropic claimed that they're better at coding than anybody else. I don't even know if that's true. They claimed it. But how do you sort of see this?
So I think a bunch of the models have definitely become quite close to one another. Some of them are slightly better in some areas, while some of the others are slightly ahead in the others. I would say, roughly speaking, our top three models in terms of just the sheer frontier of capabilities, assuming cost and latency were no consideration at all, you just wanted a pure model performance and quality of outputs, we are probably looking at the best OpenAI models, the best Anthropic models, and the best Google models at the moment. They are, I would say, roughly neck on neck. Now, as an enterprise leader, the key question often is, you're not just trying to compare who is slightly ahead of whom today. You're also trying to make a decision about where to make relatively larger investments over the next year or two. And the point is, in many important ways, even in a certain area, if one of the three companies I mentioned was, is slightly behind, it is probably still ahead of where its competitor was 1 month ago. So the point I'm making is every month or two, orderings can very substantially change. And for all practical purposes, I would say they are close in.
And I assume they're all looking at each other very, very closely and absolutely.
Oh, absolutely, absolutely. Competitive research happens all the time. In what area is our competitor ahead of us? Let's try to close those gaps. Absolutely.
How many areas do they actually? I mean, there must be thousands and thousands of areas in which you can actually compare performance, right?
That's right.
I mean, we get the big ones like software development, but there's thousands of areas that we can look at.
Yeah. That's exactly right. Now, there is there is some element of comprehensive benchmarks, I would say, across a range of areas. There are definitely areas that are somewhat light on benchmarks as well. I think the reason a lot of attention is paid to coding followed by mathematics is that repeatedly, it's been found by all these companies that improving model capabilities in these areas appears to have very nice spillover effects by way of better reasoning as a whole. Like, for example, improving its just sheer mathematical capabilities does seem to improve its capability to, say, be a good reasoner when it comes to writing a McKinsey-style report, let's say, or if you wanted to get it to engage in deep research. And same thing with even coding. So, therefore, these, of course, get a certain amount of disproportionate investment. There's certainly some areas like virtually everybody believes that to create a lot of economic value, one needs to make these models better at understanding images, video, and that kind of multimodality, where I think there's a lot of weaknesses in all models today. Since it is one thing, it is relatively simple for most of these models to tell what is in an image and all that, but very often that's not what humans want. Where humans want to upload a complex chart and accompanied by some text or a video or something else, and want the models to reason through that, since that's what a lot of economic work involves. Another one is this computer use. Like you should literally be able to talk with your model and make it do various things. Engage in certain kind of Salesforce operations, or you find out something using 3 pieces of enterprise software. There's a long way to go in many of these things, and even in real industry use cases.
So how do you improve reasoning? Is that like an algorithmic improvement, or is it also dependent on data? Like what actually happens in improving your reasoning capability?
So I would say data is a very, very big part of this. There have been a number of methods when it comes to improving reasoning. One method involved, one that we have helped a lot of the models get better at is to do with creating various detailed reasoning traces and sort of teaching the models to think in that manner. Like today, for example, when we see some kind of a problem, even in mathematics or physics in a textbook that involves some kind of reasoning, the main problem with what you see in these textbooks is that it goes from start to finish in a straight line, but that is not how humans think. Humans would bumble around. They would figure that some approach is leading to a dead end, or suppose you have to prove some property of some relatively large object. You may first really simplify it and say, okay, let me tinker around with this this toy use case, build some intuition. So there really does not exist that kind of training data on the internet, and creating that kind of training data is really valuable, because if something was readily there in textbooks on the internet, or the models would have already picked that up. So that is certainly one thing that has proved valuable. Additionally, I think quite a few things around this around various problems in mathematics and coding and things like that, where the outcome can be kind of readily verified, and you allow the problem to so you allow the model to try a whole bunch of different things, get partial rewards along the way, and so on. This too has proved quite an effective technique.
So let's switch to, you alluded to this, but let's switch to Turing itself. Like, how are you sort of helping these companies achieve their goals? You sort of alluded to at the top of the conversation, but let's go dig a little deeper. Because I know you guys are growing like crazy. So trying to understand your growth trajectory, what exactly are you doing with, what are you doing with these companies, I guess, with the the frontier model companies?
Yeah, so I would say, people, often talk about 3 ingredients of this model success, but we find, they say it is algorithms, compute, and data. We find it useful to sort of divide that data into 2 parts, really, which is pre-training data and post-training data or post-training model feedback. It is that last part that we get most involved in, basically. Essentially, it turns out that the way to, maybe let's take the simplest example, say something like 4 years ago, none of the models were even good at solving, say, lead code type of programming problems. Now, of course, they have all gone way.
What kind of problems?
Lead code. Like the thing that an undergraduate computer science student practices, or what people are generally interviewed on. For example, this is not something that involves a complex code context or something. Here's a problem and write a piece of code. That sort of thing. Not that here is a complex piece of code, understand it and make some changes, which is a different type of problem altogether. So, for example, these were not problems that any of the frontier models could do particularly well. But it turned out that engaging in first creating some sort of a taxonomy around different kinds of problems, identifying model weaknesses, and then engaging in a technique called RLHF was quite helpful. So this is reinforcement learning with human feedback. So this means that you create a taxonomy of prompts, like in this case, which are really coding problems that the model is unable to solve well. You get back a couple of suggestions from it. You rank which one is better, and in hard problems, very often even the better suggestion will be substantially wrong. You go and rewrite it, and that exact data is used to fine-tune the models. And it turns out that a relatively modest number of such examples can improve model performance substantially in a different area. So imagine that what I just described to you with lead code programming, imagine within software there is 20 other work streams like this, including doing stuff in a complex code base. Imagine we have another work stream with PhD level physics, another one with PhD level mathematics, another one with a whole bunch of finance experts from Wall Street.
Or medical diagnostics?
Yeah. We run projects with a large number of medical doctors, that's right. So that is exactly what is done. And of course, these things are prioritized very much based on what would be most valuable to the company, what is in line with their priorities. So this is the reason why I think a substantial amount of the investment ends up going in the direction of either this math or coding, because of its nice properties to generalize model reasoning across the board, or a high GDP activity. Like for example, I think OpenAI might have even released some benchmark called GDP eval or something, which is about a benchmark data set for high GDP type of activities.
Interesting. One of the things that I see referred to a lot is sort of the nature of training data changing. Mm-hmm. A lot of synthetic data being provided to these models, because basically they've scraped publicly available data and some that is not so publicly available.
Correct.
Now, what is synthetic data? How is it provided? How does it help the models improve?
Yeah. So the idea, so there are, I would say, a couple of lines of, some people, just call human feedback data synthetic data, but not very many people do that. So as a practical matter, the synthetic data comes in a few different shapes or forms. One is that you can probably exploit the fact that if you get the model to think more, it's more likely to return a correct answer. And if you were to then fine tune it with that, it can probably get it right the first time without as much thought. So that there's a concept called reflection, which is getting the model to reflect on its own answers, which is very closely tied to this concept of test time compute, that think more and increase the chance that you get it right. So this general line of attack is exploited to some extent. I don't think this is anything like a path to AGI or remotely anywhere there. This gives you something. A lot of exciting things come when one is able to still get human feedback in, but maybe do it in a manner that is even higher ROI. So, and there comes, for example, one technique that has become really popular this year, and I expect that to, there is so much to milk there in terms of model improvements that I expect that to be around for some time, which is the concept of something called a reinforcement learning gymnasium, or an RL gym in short. So the idea behind this is you put together various simulation environments that resemble what you do in everyday work. So for example, you could have an RL gym for Salesforce, another one for ServiceNow, another one for QuickBooks, another one for Slack, all sorts of, even for consumer software like DoorDash. And the idea is you'd then design a whole bunch of scenarios in this, and you'd write something like a verifier that allows the models to, allows for some kind of automatic checking regarding whether the model got it right or wrong. So for example, let me describe a sample scenario to you. So imagine we put an simulated version of Salesforce together. We may have a sample scenario that says, I'm an account executive for this company. I got this purchase order from a client. Please go and make the necessary changes in Salesforce. Then you just let the model do its thing, and then your verifiers might be rules like the following. After the model did its thing, is there an account that got created by this name? And if the account got created, is there an opportunity by this specific name, matching what was in the PDF, for example? And within that, was there a budget amount equal to something else? And the idea is you can give partial rewards to all of these things, and you can allow the model to try thousands of times or millions of times under this reward structure. So generally, if one were to go and create, say, 100 or 200 different simulation environments with 50 scenarios in each one, you have 10,000 interesting scenarios for these models to play with, run thousands of reinforcement learning runs, and the model can substantially get better here. So the humans still have to do the work in terms of constructing the RL gyms. Then you need experts from the specific domain. Like if it's QuickBooks, you need to get people with an accounting background to create those realistic scenarios. You don't want to create something that's total fiction. But it turns out the model can do thousands of runs or something within that. It can generate synthetic data to fine-tune synthetic data can be generated to fine tune the model, all of that.
This is because in my world, sort of synthetic data is really you have some statistical distribution and you sort of generate, a data set based on the following the distribution. You get your students to sort of find the underlying model, for example. But one of the things that struck me when you were speaking is there's a lot of sort of human feedback. I mean, there's a lot of manual intervention. This is like sort of painfully, at some level, improving the model. You've got to recruit the right talent. They've got to evaluate this consistently. It's not some magical process where you set these machines loose on the data and because that's the way the machine learning picture is always sold, right? It's like, hey, you just set them free. They watch humans do whatever, and the next thing you know is they understand all these things and they sound pretty smart. But the reality is that there's a lot of not physical is not the right word, mental work from a lot of people that actually helps, because it's almost like the next level is coming from human experts. It's not coming from scraped data. I mean, I'm sure it's a mixture, but
yeah, that's exactly right. I think the scraped data lays a fairly good foundation, but that does not make the model sufficiently usable at all. At least as of now, in terms of what, I mean, people have been dreaming for a while about, the capability for models to self-improve and all that. People are a little bit more excited about RLHFs for this exact same reason, because they have not taken the human out of the loop, but with the same human effort, they are able to get a lot more out of it, and they are hoping to improve the ratios.
No, and the value to me, which I think is interesting, which is the way all software works, is the moment you get one good idea implemented in software, then you can scale it, right? Then 100 million people can use that improvement every single month or every single day.
That's right.
And I think that is, so there's still, this is interesting. It's eye-opening, actually. I want to ask you, I'm sure people are wondering here, what are some of the advancements? So, you have an inside view of these companies. What are some of the things that you're seeing, and maybe you can only share a limited piece of this, that will surprise us? Like where is, are there things that they're building that will say, oh, wow, they can really recognize this image, because you mentioned, I'll give you a funny story. Like there was this time when it said, draw a picture of me at whatever I do. Now, I never told it I was a professor. And it said, so drew a picture of me as a professor. Somehow I'd figured that out, but gave me a lot of facial hair. And I said, get rid of the facial hair. And next, so took off the head, but it didn't take off, give me a beard. And I'm like, no, but it didn't. And I said, okay, to remove the beard, I didn't have any idea what I was talking about. I still got the same picture and over. So I think there's a lot of scope for improvement, but what do you see on the horizon?
Yeah, so you're absolutely right. Like in the area of multimodality, I think there are a lot of holes specifically. Like even there are even a lot of I would say fundamental questions in terms of how to even properly embed these multimedia. Like for text, it's I think the methods have been fairly standardized for a while, and texts are not that rich in data. One doesn't have to. Not that large data, and one doesn't have to think about various approximations for them. So certainly learning how to do multimodality well is a big part of it. I would say, well, the pace of progress is definitely very, very astounding, right? These vibe coding tools are getting a lot better. Difficult to use them in a lot of production settings, but they are great for putting together prototypes. Like in the past, it was not really practical for product managers to put together a quick and dirty prototype of something to even discuss whether something is worth doing or not, or put that in front of customers before actually consuming real engineering resources. All that is quite possible now. These coding agents are definitely getting a lot better. There's a lot of ambitious efforts in these companies. The reality is, vibe coding platforms like Replit, Lovable are doing really well. They have gone like from virtually sub 5 million ARR to more than 100 million ARR in under a year, and so on. So there is definitely a lot here, and as these models get better, this too will do a lot. I fully expect, for example, one thing to come a lot more, at least in the larger enterprises, is some of these enterprise-specific RL gyms. At the moment, I think most of that activity is with the frontier AI companies, but as specific enterprises with their proprietary data and everything attempt to automate big chunks of their work, they may well engage in some investments in that direction.
We'll close with one final question. So the audience here is, they use the frontier models, but everybody's working hard to figure out how to adopt generative AI in their businesses. When both the technology is advancing super fast, and obviously there's a lot of uncertainty about how this world is going to transform geopolitically, but also around technology. What advice would you share in terms of capturing value from their AI investment? Because I think some of what we're calling failure of AI investment is really a reluctance to spend what it would cost to scale these fully, because they're not completely convinced that it might be. But that's my interpretation.
Yeah.
How do you think about
it? That is part of it. So I would say, if you're a sort of, if you're not one of these frontier AI companies, you're an enterprise that's looking to create business value. In my opinion, there's at least one thing, in my opinion, everyone should do. There's a second thing you could consider doing or not do, depending on your ambitions. And maybe also depends a little bit on whether you've done anything at all with the first step. So the first step, I would say, is really try and identify some problems that are at the intersection of three Venn diagrams. First one is large business value. Second one is it should be something the AI is capable of doing well today, as opposed to some futuristic promise. I'm sure it can do a lot more 2 or 3 years from today, but maybe it's good to pick something that the LLMs can do sufficiently reliably today, let's say with 95% accuracy or something. And the third one is, don't pick a problem which is something that literally deserves needs 100% accuracy, where even 0.01% error rate will hurt you. Don't get into those problems, because that will never see the light of the day, basically. So if you were to pick problems that satisfy these conditions, there is a lot of business value to be created. Very often, I think, part of the reason for the AI ROI not coming maybe because of what you're saying, but I do think very often many of those things do not satisfy these conditions at all. Like there is and why it does not satisfy these conditions is I very much suspect the bigger hole in most people's understanding is on number 2, which is understanding the boundaries of the model capability. And this can be a little difficult to do unless you have a tech team that is actively on top of this, because that boundary is kind of changing every day. But you at least want to have some rough sense of where that boundary is, and that is how one might go around doing this. So, for example, some of the projects we have done with a number of large enterprises that satisfy these conditions are an auditor co-pilot, which has helped to optimize a lot of expensive audit workflows, ensure that the relevant teams have this kind of co-pilot at their disposal, and are, whatever they submit to the auditor is already, say, 95% right rather than, 70% right, needing fewer iterations and everything. We have done an insurance underwriting co-pilot as well. We have done another one to help these client relationship people at large asset management firms handle their high net worth clients better, answer their queries, or put a first draft of a response together automatically, and so on. So I think if one were to pick the right problem that falls in this intersection, there is a lot of value to be had. And the good thing is a lot of things can be sort of tested pretty rapidly. It's also worth giving yourself something of a learning budget. I don't even know if this MIT study accounted for that. Like, for example, even within Turing, surely a lot of people tinkered around with some things for a couple of weeks, which enabled them to learn a lot, but nobody had any hope of taking any of those to production. I mean, a couple of weeks toward education is not a bad investment. Yeah, and if one wants to go past this, and this is something I'm certainly seeing with some of our Fortune 100 clients who have already done a lot of things that roughly fit this description. Some of them do choose to play bigger, like, for example, creating a finance LLM on top of their proprietary data, or creating these specialized RLGMs for their business use case, which can help them improve all the thousands of agents they are building in different parts of the company, etc. Those are definitely interesting areas one can get into if some investment has happened in this first area.
Thank you so much, Vijay, for a fantastically informative session.